Hello everyone and welcome to Lecture 14. Here's our plan for today. We'll review variation series and their characteristics, then define what dispersion is. We'll introduce the rule of addition of dispersion, also known as the law of total variance. We'll define total variance between group variance and within group variance, and see how they relate to each other. We'll work through a detailed example, discuss interpretation, and finish with practical applications. Let's start with a quick review. A variation series is an ordered sequence of data with corresponding frequencies. It can be discrete with individual values or interval with grouped classes. The key numerical characteristics we use are the mean, which is the average value, the variance, which is the average squared deviation from the mean, and the standard deviation, which is the spread in original units. Now here's an important question. How can we analyze variance when data is divided into groups? For example, we might have data from different factories, different schools, or different treatment groups. The answer is the rule of addition of dispersion. Dispersion, also called variation, measures the spread or variability of data around the mean. Why do we study dispersion? First, it helps us measure the reliability of the mean as a representative value. If the dispersion is small, the mean is a good summary. Second, it helps us identify whether the data is homogeneous or heterogeneous. Third, it allows us to compare variability between different groups. There are three types of dispersion we need to understand. Total variance measures the variability of all data combined. Between group variance measures the variability between different group means. And within group variance measures the variability within each individual group. The key insight is that total variance can be decomposed into these two components. The rule of addition of dispersion, also known as the law of total variance or variance decomposition, is a fundamental concept in statistics. The main idea is simple but powerful. The total variance of a dataset can be split into two parts. The first part is the variance between groups, which is due to differences between the groups themselves. The second part is the variance within groups, which is due to differences within each individual group. The formula is total variance equals between group variance plus within group variance. Why is this rule important? First, it helps us understand the sources of variability in our data. Second, it's used in ANOVA, or analysis of variance, which is one of the most important statistical techniques. Third, it helps us evaluate the effectiveness of our grouping. If most of the variance is between groups, then our grouping is meaningful. If most of the variance is within groups, then our grouping may not be very useful. Before we dive into the formulas, let's establish some notation. Suppose we have data divided into k groups. For each group I, n sub I is the size of that group. N is the total sample size, which is the sum of all group sizes. X bar sub I is the mean of group I. X bar is the overall mean of all data combined. With this notation, we can define three types of variance. Total variance is the variance of all observations around the overall mean. Between group variance is the variance of group means around the overall mean. And within group variance is the average of group variances weighted by group sizes. Each of these measures a different aspect of variability in our data. Total variance, denoted sigma squared total, measures the variability of all observations around the overall mean. The formula is the sum over all groups and all observations of the squared deviation from the overall mean, divided by the total number of observations. Here, x sub ij is the jth observation in group I, and x bar is the overall mean. This is the total variability present in the entire dataset. It tells us how spread out all the data points are, regardless of which group they belong to. Between group variance, denoted sigma squared between, measures how much the group means differ from each other. The formula is the sum over all groups of each group size times the squared deviation of the group mean from the overall mean, divided by the total number of observations. If between group variance is large, it means the groups are very different from each other. Within group variance, denoted sigma squared within, measures the average variability within each group. The formula is the sum of each group size times the group variance, divided by the total number of observations. If within group variance is large, it means that data within each group is spread out and heterogeneous. If it's small, it means that data within each group is tightly clustered and homogeneous. There's an alternative formula for within-group variance. It's the sum of squared deviations from each group mean divided by the total number of observations. This is often easier to compute in practice. The interpretation is the same. Large within-group variance means data is spread out within groups, and small within-group variance means data is tightly clustered within groups. Now let's look at the fundamental identity of the rule of addition of dispersion. It states that total variance equals between group variance plus within group variance. In words, total variability equals variability between groups plus variability within groups. This identity is the foundation of analysis of variance. The proof involves expanding the total sum of squared deviations and showing that it splits naturally into these two components. This is a powerful result that allows us to understand exactly where variability in our data comes from. What does this rule tell us? First, it tells us about the sources of variability. Differences between groups contribute to total variance, and differences within groups also contribute to total variance. Second, it helps us understand our grouping. Let's work through a detailed example. Suppose 3 factories produce the same product and we measure quality scores from each factory. Factory A has scores 80, 85, and 90. Factory B has scores 70, 75, and 80. Factory C has scores 60, 65, and 70. We want to find the total between group and within group variances. First, we calculate the mean for each group. For Factory A, the mean is 80 plus 85 plus 90 divided by 3, which equals 255 divided by 3, giving us 85. For Factory B, the mean is 70 plus 75 plus 80 divided by 3, which equals 225 divided by 3, giving us 75. For Factory C, the mean is 60 plus 65 plus 70 divided by 3, which equals 195 divided by 3, giving us 65. Then we calculate the overall mean, which is the average of all 9 scores. 85 plus 75 plus 65 divided by 3 equals 225 divided by 3, which is 75. First, we find the variance of each group. Each group has scores that deviate from their group mean by 5, 0, and 5, giving squared deviations of 25, 0, and 25. The sum for each group is 50. The total sum of squared deviations within groups is 150. Dividing by 9 gives us approximately 16.67. Finally, we verify the rule by calculating the total variance directly. We take all 9 scores and compute the squared deviations from the overall mean of 75. The sum is 25 plus 100 plus 225 plus 25 plus 0 plus 25 plus 225 plus 100 plus 25, which equals 750. Dividing by 9 gives us approximately 83.33. Now we check the rule. Total variance equals between group variance plus within group variance. 83.33 equals 66.67 plus 16.67. The rule holds. This confirms that total variance is indeed decomposed into between group and within group components. This example demonstrates the power of this decomposition. The rule of addition of dispersion has many practical applications. In quality control, it helps identify whether variation in product quality is due to differences between machines or within machine variability. Let me summarize what we've learned today. The rule of addition of dispersion states that total variance equals between group variance plus within group variance. Total variance measures the overall variability in the data.